In this video, we're going to show the auto switching configuration that appears on many of our bidirectional amplifiers. In this demonstration, we're going to use our TTRM 1004 amplifier, which is a 25 watt S-band unit that's capable of basically any modulation type, any signal type, from FM to OFDM. This is the equipment we're going to use to test and measure the auto switching function of the amplifier. We're going to use the signal generator to create an OFDM signal, very similar to the one used in an 802.11g access point. We're going to use the oscilloscope to measure both the output burst of the signal generator and the RF output of the amplifier. As we go to the rest of the test setup, we can see the amplifier output hooked up to a load and a coupler, and right here is our RF detector that is fed back into the oscilloscope that's going to measure the voltage generated by it. So right here we have a very similar unit to the one that's hooked up to the bench, and just to describe the switching circuitry a little, the auto switching is basically initiated by an RF surface mount coupler on the input of the amp, which feeds to a calibrated detector, some comparator circuitry, which will time and sequence the transmit and receive the PA and LNA portions of this bidirectional. So now we're going to turn on the signal generator. We're actually going to start at an input power that's not going to have the amp auto switch. It's going to be too low for the detector. So turning the generator on, we can see that the input signal is now feeding into the amplifier, but the detector has not peaked because the amp is not on yet. So we raise the input power to the threshold, which is about 0 dBm, where it starts switching. You can see that now the amp is reacting to the input burst, the input RF burst. If we turn the power up a little more, see that power level go up. And we've offset the traces just so that you can see the yellow trace is the RF signal generator's output burst, and the blue trace is the RF output burst of the amplifier. What's important to note here is how quickly the amp reacts to this. On the rising edge, we can see that within about 800 nanoseconds, the amp has turned on after detecting the RF transmit burst. This is important because if it turns on too slowly, the RF burst, the RF packet, you will lose information, and the radios may not be able to communicate, or communicate with a lower than peak data rate. On the falling edge, you can see the turnoff is even a lot quicker. The amplifier turns off in about 200 nanoseconds or so, which is also very important because after the transmit burst disappears from the RF input, the radio port of the amplifier, it needs to be off with the LNA on very quickly, ready to receive the next transmission from the radio on the other side. So that's a summary of how the auto switching works on our bidirectional amplifiers.